Yeah, I think I recorded this video one time and then I forgot to basically turn on my audio, so I have to record it again. So, anyways, let's get started with this problem today. So, our problem today is longest repeating character replacement. Let us first read the problem statement and see what it wants us to compute. So, here goes the problem statement. You are given a string s and an integer k, and you can choose any character of the string and change it to any other uppercase English letter. You can perform this operation at most k times, return the length of the longest substring containing the same letter you can get after performing the above operations. So basically what the question wants us to compute is the longest range length in the string in which we can make at most k flips so that all the letters in this range become the same. So that is the question demands from us. So how do we do that? Okay, I'm straight away jumping into the solution idea of this problem. How do we do that? So basically what we do is we'll find the element with the largest frequency, right? Suppose in this substring we'll have f which has the largest frequency, and its frequency is suppose 3. It is suppose here, here and here, and all the elements on the left and right of all these f's are other elements which are not f. So but their total number is less than equal to k, right? Then as per the condition of the problem we are allowed to flip all of them, right? And then obviously we want to make all the elements of this substring same, so we'll flip them to f. So all of those elements would become f, and then we'll for at least for this range we'll be achieving what the question wants from us, and then we'll be kind of computing this range length, and then we'll basically uh, through some algorithm which I'm going to explain shortly, we'll compute all such ranges which are possible and take the maximum range from there, range length from there, and that should be our answer, because that is what the problem wants us to return from the function, right? And then so this was kind of on a broad view how we'll do it. To get to some more finer details, what we'll be doing is we'll basically have a left pointer, right, and we'll have a right pointer, and obviously all the elements which are coming between this left pointer and right pointer in this continuous range will be the substring which we are investigating. And what will be investigated in this substring? So our objective is to make all the elements of this substring the same. And in order to do this, what we'll do, we'll figure out the element with the maximum frequency, and then we'll figure out the length of the other elements that are there, right? So that will be basically the number of elements having the maximum frequency. If we deduce, if we deduct it from the range length, total range length bounded by this left and right pointer, will be arriving at the number of elements which are not the same as the element with the maximum frequency, right? And if that number of elements is less than equal to k, that means we'll be allowed to all flip all those elements. And since we want to make all the elements in this particular range which is defined by the left pointer and right pointer same, we'll be flipping all of them to the element having the maximum frequency. So that is what we will be doing. And then what if we don't satisfy the criteria? That means we are required to do far more flips than we can. So we need to reduce the length of the array, so we'll be shifting the left pointer forward. And then if our condition is satisfied, then we'll be shifting our right pointer forward, because we our objective is to find the maximum substring, so that this criteria is can be satisfied. So once we reach a substring which satisfies the criteria, we have to expand its length, and so as to find a better answer if possible, right? And to do that, we'll be moving the right pointer rightwards. So now let's get into the code and see how it is done. So we'll initialize an unordered map, because there is no reason to keep an ordered map. This map captures element as the key and the frequency of it as the value in a key value pair, which is what a map stores. And then we'll be basically initializing the element n to s dot length. Just for ease of computation, we'll be initializing our left or right pointers. Both will be at 0 initially. We'll basically obviously, since we have both the pointers are at 0, that means the range length only contains the 0th index element. So we'll be basically populating, will be filling the map with that element as the key, and basically is one as the value, because there is only one element, so it will be, the value will be one. For a frequency map, will be have our minimum maximum range length will be initialized to one, because worst case scenario we can have only one letter, right, in our substring, but and then we don't need to do any flips, and since there is only one letter, so all the letters in the substring are same, so worst case scenario max range length will be one. And max value is basically stores the for a particular range, the maximum frequency of the sorry, the frequency of the maximum element. It stores the frequency of the maximum element. And then worst case scenario, it will be one, because again for a substring which is only one element, so the frequency of that element is one. Now we basically start our while loop. We'll have some sanity checks for that. These are very easy to understand sanity checks. Basically, the left pointer cannot go beyond right of the right pointer, and the right pointer obviously has to stay within bounds. And then obviously we'll figure out the maximum the frequency of the element having the maximum frequency stored in the max value by going through all the elements of the map. And then we basically check whether our condition is satisfied. Here we are once we have collected the frequency of the element having the maximum frequency, we'll figure out the number of other elements by deducting it from the range length to give us the number of other elements. And if that element number is less than equal to k, then obviously we can flip all those elements to the same to the element having the maximum frequency in order to make all the elements in the range the same. And then we calculate this range, and then we update the max range length if required. And then we increment the right pointer, because we have already kind of have a substring which satisfy criteria, so we need to make the substring larger, because maybe there is a better there is a larger length substring, and hence our answer can be improved. So, and then there is a sanity check, and then to just to check whether the right pointer is not going out of bounds after the right plus plus, after basically moving the right pointer one step right. And then basically we'll update the map. And then if our condition is not satisfied, that means we are having to make too many flips. That means we need to reduce the size reduce the range size, and that means we'll be moving the left pointer one step to the right. So we'll be, before doing that, we need to obviously since our left pointer has moved one step to the right, so we need to remove that element which is just moving out of the range from the map. So that is being updated in this line. And then obviously if after reducing the frequency of the element which is just about to be moved out of the range, the I mean the frequency of that element goes to zero. That means the element is no longer in the new range, so it has to be removed from the map. And then obviously after doing that, we increment the left pointer one step to the right. And then after completion of the while loop, we'll be having our max range length which we need to return. Hopefully you understood this problem. This is not that difficult to understand. This is easy enough, but if you find any difficulty understanding this problem, then you can just have a relook at the video, think about it for a moment, and I'm pretty sure you'll be able to understand this video. So with this, this is the end of this video. I'll see you in the next video. Thank you. Bye.